Alright, welcome. In this video, I'm going to be recording solutions for the CalBC Unit 4 quizzes. And so the first one's about implicit differentiation. We're going to start with x to the 3 plus e to the y equals y plus 3, and we're going to find dy dx. Let's see. Alright, so we're going to start by taking the derivative of both sides with respect to x. So we know that the derivative of x to the 3 with respect to x is 3x squared. And the derivative of e to the y with respect to x, okay, well, on the outside, I've got e to the thing, and on the inside, I've got y. Okay, when I take the derivative of outside, we know the derivative of e to the thing is e to the thing. And the derivative of y is going to be dy dx. Okay. And so the derivative of e to the y, we're going to multiply outside prime times inside prime, and that's going to be e to the y times dy dx. And that's going to equal the derivative of y plus the derivative of 3. Okay. Then we're going to collect everything that has dy dx to one side of the equation. And so we'll have dy dx minus e to the y dy dx. Okay, I guess I'm switching sides on this equation, but that's going to be equal to 3x squared. Okay, then I can factor out the dy dx. And divide to solve for dy dx. With the second one, we're going to start with dy dx and need to find the second derivative of y with respect to x. Okay, so again, we're going to start by taking the derivative of both sides. So the derivative of dy dx with respect to x is the second derivative of y with respect to x. And then we're going to need to use the product rule. Okay, the derivative of x squared is 2x. We'll leave sine y the same. And we'll add, leaving x squared the same, taking the derivative of sine y. And because sine y has a y in it, we know that we need to use the chain rule. So on the outside, I've got sine of the thing, and on the inside, I've got y. And the derivative of sine is cosine. Derivative of y is dy dx. Okay. So we know that the derivative of sine y is going to be outside prime, cosine of y, times inside prime, dy dx. Okay. But it says in terms of x and y only. Okay, so we need to get rid of that x, dy dx. Okay, we're just going to substitute. We know that dy dx is x squared times sine y. So we're going to go over here and we're going to say, all right, this is 2x sine y plus x squared cosine y times x squared sine y. And if you wanted to, like combine that to make x to the fourth cosine y sine y, you could, or you could just stop there, right? Okay. Now we're going to write an equation for the line tangent to the graph of x to the 3 minus 2xy equals x plus 1/2 y squared at the point where x is negative 2 and y is positive 2. Okay, so I've already got a point, now I just need a slope, so I'm going to take the derivative of both sides with respect to x and hopefully find dy dx. Okay, so the derivative of x cubed is 3x squared. Okay, I'm going to look at this as the derivative of negative 2x and positive y, and I'm going to use the product rule. So the derivative of negative 2x would be negative 2, leave y the same, and then I'll leave negative 2x the same and take the derivative of y, and I'll have dy dx. Okay, and that'll equal the derivative of x plus, okay, the derivative of 1/2 y squared would be 1y times dy dx for the chain rule. Okay. And what was I thinking here? Okay, yeah, if I'm just asking you to find dy dx, that's where we're going to need to collect everything that has dy dx to one side of the equation and factor it and then divide. But if we're just looking for the slope, we can just plug in x equals negative 2 and y equals 2 right now. So I'm going to do that. So I'll have 3 times negative 2 squared minus 2y minus 2x, so that would be plus 4 dy dx equals 1 plus 2 dy dx. Okay. So I've got 12 minus 4, that's 8 plus 4 dy dx equals 1 plus 2 dy dx. Okay. So I think I might subtract 1 from both sides, and maybe subtract 4 dy dx from both sides as well. And I'll get dy dx equals negative 7 halves. And now that I've got a point and a slope, I can write the equation. It's going to be y minus 2 equals the slope, which is negative 7 halves, times x minus negative 2. Alright, number 4 is going to ask us about this curve, and does the line tangent to this curve sit above the curve or below the curve? Okay, when they ask that, we're going to need to find the second derivative to determine if the curve is concave up or concave down. So we're going to go over here and we're going to find dy dx first. So the derivative of 3x plus 12, that's just going to be 3. And the derivative of log of something is going to be 1 over that thing times the derivative of that thing. Okay, so the derivative of x plus y is going to be the derivative of x plus the derivative of y. Okay, and now I'm going to start solving for dy dx, I guess, by multiplying by x plus y. So we'll have 3x plus 3y equals 1 plus dy dx. Okay, and then I'll solve for dy dx by subtracting 1. Okay, and then to get the second derivative, this should be pretty easy, compared to ones that come back where dy dx is a quotient. This will be 3 plus 3 dy dx. Okay. I think this should be enough. I don't think we really need to go back in and substitute on dy dx. Then we can just compute them separately and then determine the sign of the second derivative. Okay, at the point negative 4 and 5, dy dx is going to be 3x, so that's negative 12, plus 3y, that's plus 15, minus 1. Okay, so that's going to be 3 minus 1 is 2. And then the second derivative, that's going to equal 3 plus 3 times 2, which is certainly greater than 0. Okay, and since the second derivative is greater than 0, we know that the line tangent is going to sit below the curve, right? Just draw something that's concave up and then draw the tangent line, and you'll see that tangent is going to sit below the curve. So I'm going to say, because of that, below the curve. Okay, suppose y equals f of x is a solution to this differential equation. Okay, and they're going to ask if it's a relative maximum, relative minimum, or neither at a point where x equals 3. Okay, this one we have to use the second derivative test. We don't have enough information about f of x to use the first derivative test to say, before and after x equals 3 is the sign of dy dx changing. We don't know what the y coordinate is. Okay, so what we're going to do is we're going to check dy dx. And if dy dx comes back not 0, then we would say neither. But usually it's going to come back 0. So it's going to be 2x is going to be 2 times 3 minus y squared, square root of 6 squared is going to be 6, and that's 0. So that means we might be sitting in an extrema. And in AP Calculus, we probably are if dy dx is 0. Okay, we're going to need to take the second derivative. So the derivative of 2x is 2, and the derivative of y squared is 2y dy dx. Okay. And then I'm going to find the value of the second derivative at the point they gave me. It's going to be 2 minus 2 times the square root of 6 times 0. Okay, so that's going to be positive. Okay, and since the, whoops, you can't see that. Okay, and I'll say, okay, because the second derivative is positive and the first derivative is 0, I'll say we're at a relative minimum. Right, number 6, it is known that for the curve y squared minus 2y minus 40 equals x squared plus 4x minus 1, dy dx is x plus 2 over y minus 1. Determine the xy coordinates of any point where the tangent of the curve is horizontal. Okay, I feel like I might have changed this problem on one of the forums when we actually took this quiz in class. Let me think about this. I don't think I would have changed this. This looks like it's going to work out fine. Okay, so tangent to the curve is horizontal. Okay, that means that dy dx equals 0. Okay, and that's going to mean that x plus 2 has to equal 0, while y minus 1 is not equal to 0. Okay, so x plus 2 equals 0, that's x equaling negative 2. Okay, and now we're going to find the y-coordinate by just plugging back into the original equation. And so we'll have y squared minus 2y minus 40 equals x squared, that'll be positive 4, plus 4x is negative 8, minus 1. Okay. So if I've got 4 minus 9, that's negative 5. I can add 5 to both sides. I can factor. And I can get some values of y. So I'll have y equals 7 and y equals negative 2. Neither of those are y equals 1, which would cause me to have 0 over 0 dy dx, which is something we don't talk about in AP Calculus. So the xy coordinates of the horizontal tangents are negative 2 and 7, and negative 2 and negative 2. Alright, now let's work form J. So suppose x to the 3 plus sine y equals y plus 3, find dy dx. Alright, so we're going to take the derivative of both sides of this equation with respect to x, and so the derivative of x to the 3 is 3x to the 2. The derivative of sine y is going to be cosine of y times dy dx for the chain rule, and that'll be equal to the derivative of y plus the derivative of 3. And so now I'm going to collect everything that has a dy dx to one side of the equation and then leave everything else on the other side. So it would be 3x squared equals dy dx minus cosine y dy dx. And then I'm going to factor out the dy dx. And I'll solve for dy dx by dividing both sides of the equation by 1 minus cosine y. That's all they asked for. Find dy dx. Okay, now they're going to give us dy dx and ask us to find the second derivative in terms of x and y only. Okay, so when we take the second derivative, when we take the derivative of dy dx, that's going to incur a dy dx when we take the derivative of e to the y. And then we're going to have to substitute on that to make sure it's just in terms of x and y only. So we're going to use the product rule, take the derivative of dy dx with respect to x, and that'll be the second derivative of y with respect to x. And then I'll use the product rule, that's derivative of x squared, 2x, leave e to the y the same. Then add, leaving x squared the same, the derivative of e to the y with respect to x, and that's going to be e to the y times dy dx for the chain rule. Okay, and then here I need to substitute on this dy dx to make sure it's in terms of x and y only, and I'll use x squared e to the y. I'll say this is 2x e to the y plus x squared e to the y times, well, x squared e to the y. Okay, and we could simplify that, or we could just not. Okay. We're going to write an equation for the tangent line to the graph of x to the 3 minus xy equals x minus y squared at the point where x is negative 1 and y is negative 1. Alright, so we've got a point, we need a slope. So we're going to take the derivative of this equation with respect to x, and we'll have 3x squared. Okay, I'm going to use the product rule, x times y, looking at negative x times positive y. So the derivative of negative x is negative 1, leave y the same. Then I'll leave negative x the same and take the derivative of y. And that'll be equal to the derivative of x minus the derivative of y squared. And then at this point I can just plug in x equals negative 1 and y equals negative 1 to find dy dx. I don't need to, solve for dy dx explicitly. That's just risking an algebra error. So I'm going to go over here, and 3 times x squared would be 3 times 1. Minus y would be plus 1. Minus x, so that's plus 1 dy dx equals 1 plus 2 dy dx. And I'll have 3 plus 1 is 4 plus dy dx equals 1 plus 2 dy dx. And it doesn't make me wonder if I made an error on the other version of this question, but too late now. I'm going to subtract 1 from both sides and subtract a dy dx from both sides and see that the slope is going to be 3. Okay. And then I'm going to say, okay, I've got a point and a slope, so I can write my equation. Y minus the y coordinate is equal to the slope times x minus the x coordinate. Okay, and that's an equation for the tangent line. Okay. Now they're going to give us a curve and ask if the tangent line sits above or below the curve. And that's just asking about the sign of the second derivative. So we're going to need to take the first derivative and then take the derivative of that to get the second derivative and check the concavity. So we're going to start by taking the derivative of 3x minus 12, and that'll be 3 minus 0. That's going to be equal to the derivative of log of x plus y. The derivative of log of a thing is 1 over that thing, maybe times the derivative of that thing for the chain rule. And the derivative of x plus y is going to be 1 plus dy dx. Okay. So if I want to eventually take the second derivative, I should solve for dy dx. So I'm going to multiply both sides by this x plus y. So I'll have 3 times x plus y is going to be 3x plus 3y. And that'll equal 1 plus dy dx. Okay, and then I guess I could subtract 1 and get dy dx equals 3x plus 3y minus 1. And then the second derivative would be 3 plus 3 dy dx. Okay, so now I'm going to plug in the point 4 and negative 3 and try to figure out what the sign of the second derivative is. Dy dx is going to be 3x plus 3y minus 1. Okay, so that's going to be 2. Okay, and then the second derivative is going to be equal to 3 plus 3 times 2, and that's a positive number. So since the curve is concave up, the tangent line sits below. Must be narrow. Alright. Now we're going to suppose y equals f of x is the solution to the differential equation y squared minus 3x is dy dx. If f of 5 is the square root of 15, is there a maximum, a minimum, or neither on f at the point where x equals 5? Alright, so we're going to have to use the second derivative test. We're going to test dy dx at the point they gave us. It's going to be y squared minus 3x, and that's 0, so I have a potential extremum. And then the second derivative at 5 and the square root of 15, well, I'm going to have to take the second derivative first, but it shouldn't be too hard to find. If I have dy dx equals y squared minus 3x, I could take the derivative of both sides of that equation, and I'd get the second derivative of y with respect to x is going to be 2y dy dx minus 3. Okay. So this would be 2 times y times dy dx minus 3 is going to be a negative number. And since the derivative is 0 and the second derivative is negative, I'm going to say I'm at a relative maximum. Okay. And then the last one for quiz 4.1 is determine the xy coordinates of any point where the tangent to the curve is horizontal. Okay, I think this is the one where I had to adjust it somehow. I don't know, maybe I just changed it for no reason, but it looks like it's going to work to me. If it says horizontal, so if it's horizontal, then dy dx is going to equal 0. And that that would happen because the numerator of the fraction was equal to 0 and the denominator was non-zero. But we don't really talk about where dy dx equals 0 over 0 in AP Calculus. This would be where x is negative 3. And then, so I'm going to plug in on the original equation to find the y-coordinate and get my xy coordinates of any point where the tangent is horizontal. So y squared minus 2y minus 79 is going to equal x squared, so that's positive 9, plus 4x would be minus 12 plus 4. Okay, so 9 minus 12 plus 4, that'll be 1. And I could set this to 0 so I could solve it. And notice I can factor that. That's going to be y minus 10 times y plus 8. And that will be equal to 0 when y is equal to 10, or maybe when y is equal to negative 8. So my coordinates are going to be negative 3 and positive 10, and negative 3 and negative 8. And that's all for quiz 4.1. Quiz 4.2 was over linear approximation. And the first one, I think that had been the easy one on previous versions of this quiz, but the way I asked it this year, it seemed like it was a little tricky. So the tangent line passes through these 2 points, and it's tangent at x equals 2, but it's going through these 2 points that are kind of equally spaced around x equals 2. So what I'm going to do is I'm just going to draw a little picture for you. Here's the point 1, 7, and that's going to be the point 3, 13. Okay. If this is the tangent line, then the slope of the tangent line is going to be f prime of 2. I think a lot of people knew to do rise over run on these 2 points. In this class, oftentimes when you get given a pair of points, you're going to do rise over run on it. So the slope of the tangent line, that's going to be 13 minus 7 over 3 minus 1. Okay. But f of 2 is going to be, well, we know that it's tangent right there at the middle. And, well, we don't know if it's concave up or concave down, but we do know that the y-coordinate there, because this is a line segment, is going to be halfway between 7 and 13. So we know it's going to be, 2 and, that would be 10. So f of 2 is going to equal 10. Okay, you could even use the midpoint formula from geometry. That's something that we haven't used yet this year. But that's going to be how we did the first one. Here we've got a portion of the graph of the derivative shown and a point on the graph of the original function. Okay, so writing an equation for the line tangent to the graph of g, okay, the point is going to be x equals 1 and y equals 5, because g of 1 equals 5. The slope is going to be g prime of 1, which I'll get from the graph right there. It's going to equal 3. And then I can write the equation using point slope form. Y minus 5 is equal to the slope times x minus 1. Okay. And then if they want us to use linear approximation to estimate the value of g of 0.96, I might just plug in 0.96 in for x right there, and then solve for y, and say that's my approximate value for g of 0.96. So it's going to be approximately equal to, I'll add that 5 over there, so 5 plus 3 times 0.96 minus 1. And, if this is multiple choice, I'd get into the arithmetic, but on a quiz or free response or something like this, I'm just going to stop there. Okay. And then they're going to ask, is that estimate an overestimate or an underestimate? And to give a reason. Okay, so that's going to have to do with the concavity of g, right? We're going to be thinking, if the graph of g is concave up, the line will underestimate the function, and if the graph of g is concave down, then it'll be the opposite, and it'll be an overestimate. Okay, so g double prime of x is going to be positive near x equals 1 because of the fact that g prime is increasing, right? As we move left to right, the graph is going up. Okay, so I'm going to say g double prime of x is greater than 0. Really, the best answer is to say that it's always greater than 0 between x equals 0.96 and x equals 1, but you're good enough. It's in AP Calculus, it's good enough to just say g double prime of 1 is positive. But this really is what guarantees that it's going to be an underestimate. Okay, so if it's concave up, the tangent line sits below, and it would underestimate the curve. So my estimate for number 3 is an underestimate. All right. Now on the back, start you off with a differential equation, and there's going to be 2 different solution curves. All right, so we're going to start off by finding the second derivative. We're just going to take the derivative of both sides of that equation they gave us, and we'll take the derivative of 2x, the derivative of negative 3y, and the derivative of 4 is going to be 0. Okay? But it says in terms of x and y only again, and just like the ones on the other quiz. So we're just going to substitute on dy dx with 2x minus 3y plus 4. And you can distribute if you want, but I think you're safer to just, stop there. Okay, now they'll ask if f has a maximum, a minimum, or neither at x equals 1. Okay, so we're going to use the point x equals 1 and y equals 2 because f of 1 is 2. And I'm going to check dy dx at 1 and 2. And that'll be 2 times 1 minus 3 times 2 plus 4, and that's going to equal 0. Okay, so we're sitting at a potential extremum. And the second derivative at the point 1 and 2 is going to be 2 minus 3 dy dx's. Okay, that's going to equal 2, which is a positive number. Okay, since I've got a 0 derivative and a positive second derivative, I know I'm sitting at a relative minimum. Okay. Now we're going to write an equation for the line tangent to the graph of g at x equals 2, and we'll use the tangent line to approximate g of 2.03. Alright, so we're going to use the point 2 and 4 because g of 2 is 4. And for the slope, I'll plug into dy dx. And that's going to be 2x minus 3y plus 4. So that'll be negative 4. The equation will be y minus the y coordinate is equal to the slope times x minus the x coordinate. And then my approximation will be g of 2.03 approximately equal to 4 plus 4 times 2.03 minus 2. Then if we want to know if the estimate from number 7 is greater than or less than the true value of g of 2.03, we're going to check the second derivative at the point they gave us and just go off of that. Okay, so its second derivative is 2 minus 3 dy dx. I'm just going to copy that in. Okay, and the slope, oh, looks like I copied that down wrong. Yeah, the slope was negative 4, so that'll be a negative, and then this will become a minus there. Okay, I'm glad I caught that. Okay, so 2 minus 3 dy dx, and we know that at the point we're interested in, dy dx is negative 4. So that's going to be, at the point 2, 4, that'll be 2 minus 3 times negative 4, which is a positive number. Okay, so that means if the second derivative is positive, the graph looks like that, and the tangent would look about like that, and so g of 2.03 is over here. That's going to be, that's the estimate for g of 2.03 on the tangent line. That true value would be, somewhere about there, right above it, and the true value would be greater than the approximation, so the estimate would be less than the true value. Alright, Form J. Well, number one, you wanted to draw a picture. So the tangent line, if it goes through 2 and 7 and 4 and 19, okay, the slope of the tangent line, that's going to give you the derivative, okay? Because this is tangent at this point right here in the middle. So the slope of that line segment is going to represent f prime of 3, so that'll be 19 minus 7 over 4 minus 2. Okay, but f of 3, that's going to be, well, the y-coordinate is going to be halfway in between 7 and 19. So that's going to be, half of 26 would be 13. Yeah, 6 from 7 to 13, and then another 6 from 13 to 19. So f of 3 is going to equal 13. Then the next three were kind of all related. Let's see if I can fit those all in, yeah. So we've got a graph of f prime and a point on the graph of f. We've got f of 1 equals 3. So we're going to write an equation for the tangent line to the graph of f at x equals 1. Okay, point will be 1 and 3. Our slope will be f prime of 1. Okay, that's what we're going to get from the graph. It's right there. It's 2. So the equation will be y minus the y-coordinate equals the slope times x minus the x-coordinate. And then we'll use a linear approximation centered at x equals 1 to estimate the value of f of 0.96. Okay, so I'm going to basically just plug in 0.96 right there and solve for y and say that's my approximate value. So that would be 3 plus 2 times 0.96 minus 1, and that's going to be approximately equal to f of 0.96. Then is my estimate from number 3 an overestimate or an underestimate? Okay, we're going to be interested in a sign of f prime. Okay, so looking at the prime over here at 1, we can see that f prime is decreasing. Okay, so that means that f double prime near x equals 1 is going to be a negative. Okay, so I'm going to say f double prime of x is less than 0 for x between 0.96 and 1. And like I said on the other form, you can say that f double prime of 1 is negative, and that's going to be good enough for AP Calculus, but this is the most robust reason. Okay, because the second derivative is negative on the entire interval between the approximation point and the centering point, we know that it's going to be, okay, the tangent is the approximation, it's going to be an underestimate. Hey, I normally discourage people from using it, but in this case it's really clear what we're talking about, and I think I'm trying to say it is. Alright, on the back we've got a differential equation and two solutions. So we're going to start by finding the second derivative in terms of x and y only. So we're going to take the derivative of the equation they gave us with respect to x. So the second derivative of y with respect to x is the derivative of 2y, which will be 2 dy dx, minus the derivative of 3x plus the derivative of 4. Okay? And I'll need to get rid of the dy dx to make it in terms of x and y only, so it's 2 times, I've got a formula for dy dx, 2y minus 3x plus 4 minus 3. They're going to ask if g has a maximum, a minimum, or a neither at x equals 2. So we're going to use the point 2 and 1 because they told us g of 2 equals 1. And we're going to check dy dx. dy dx is going to be 2y minus 3x plus 4. Okay, that's going to be equal to 0. Okay, so we're sitting at a potential extremum. Then we're going to plug it in on the second derivative. It's going to be 2 dy dx minus 3. Okay, so negative 3 is negative, so since dy dx is 0 and the second derivative is negative, I am sitting at a relative maximum. Okay. Now we're going to write an equation for the line tangent to the graph of f at x equals 1. Okay, we're going to need information about a point and a slope. So the point is going to be 1 and 4. And then the slope, we have not done that yet. I'm going to do that off to the side here. Dy dx, 1 and it's going to be equal to 2y minus 3x plus 4. That looks like 9. Alright, yeah. 12 minus 3. Yeah, that's 9. Okay, so 1 and 4 is my point. My slope is that dy dx at 1 and 4 is equal to 9. So my equation is going to be y, minus 4 equals the slope times x minus 1. And then I can estimate by adding 4 to both sides and plugging in 1.02 for x. And then the estimate for number 7, is it going to be greater than or less than the true value of f of 1.02? Okay, we're going to need to find the second derivative. Okay, fortunately I've got... Oh, whoa, I didn't copy in the slope. I made another mistake on that step. Plus 9 times 1.02 minus 1. Yeah, that's a little better. So the second derivative, we showed earlier that it was 2 dy dx minus 3. Okay, so I'm going to just use that. So the second derivative at the point 1 and 4, it's 2 dy dx minus 3. Okay, this is positive. Okay, so if I draw the graph of a function that's concave up and its tangent line, I can see that, okay, the estimate, which is on the line, is going to be less than the true value. So I'll answer the question directly. I feel like there was something else I was going to say about this. No, I think that's it. Right, and then the 4-3 quiz was over related rates. And so the first 3 was just find the derivative of the formula with respect to time. Okay, so find dv dt. Okay, so if v equals 50h, and we take the derivative of v with respect to t, we're going to take the derivative of 50h with respect to t. And you could say that's like 50h prime of t. But with related rates, we usually use the other notation. We call that 50 dh dt. Okay. And then, okay, if theta equals arc sine of y, we're going to find d theta dt. Okay, on the outside, I've got arc sine or inverse sine. And on the inside, I've got y. Okay, outside prime, that is one we need to know. The derivative of arc sine is 1 over the square root of 1 minus x squared. Pardon me, not x squared, thing squared. And then inside prime is the derivative of y is going to be dy dt, because we're taking it with respect to time. All right, so it's going to be 1 over the square root of 1 minus, okay, we were taking the arc sine of y, so it'll be 1 minus y squared, square rooted, times dy dt for the chain rule. Okay. Right. 3, okay, we've got area is 2 pi rh. Okay, the r and the h could both be changing with respect to time. Okay, now sometimes the cylinder is just growing in one direction and one of these is fixed, but I don't really think we can assume that. When we were grading the quizzes, I think that if you assumed that the radius of the cylinder was fixed, that we We credited you for it, but we probably shouldn't have because there's nothing to indicate that on this drawing. Okay, but because r and h might both depend on time, they're each going to have their own derivative, and we need to observe the product rule. So dA dt, I might look at it as the product of 2 pi r and h. So I'll take the derivative of 2 pi r first, so that would be 2 pi dr dt, and leave h the same, and then I'll add in, leaving 2 pi r the same, the derivative of h. Okay, and then I've got a formula for dA dt. Okay. Now there's a liquid spill in the hallway in the shape of a circle. At 10:30 a.m., the radius of the spill is 20 inches and decreasing 6 inches per minute. What's the rate of change in the area of the spill at that time? Okay, so we've got the area formula here. We're going to take the derivative of the area formula with respect to time, because that's what they're asking for. Rate of change in the area of the spill, that's going to be dA dt. Okay, and that's going to be the derivative of pi r squared, would be pi times 2r dr dt, so we would say 2 pi r dr dt. Okay. And I think we've got everything we need there, right? Yeah, the radius of the spill is 20, and the rate of change of the radius of the spill is -6. Okay, so they must be actively cleaning it up. So there's 2 pi times 20 times -6. And that's going to be a good enough number for us. Okay. Number 5, we've got some kind of like implicit equation where the x and y coordinates are changing with respect to time. This is kind of like something we're going to study in the second semester, where an object's moving along some curve instead of just moving along the x-axis or the y-axis. Okay, so we're going to start by taking the derivative of each side with respect to time. So the derivative of y to the 4 is 4y to the 3, but y is changing with respect to time, so it has its own derivative, and we need to use the chain rule. Okay. Then I'll look at -2xy as a product of -2x and 1y. So I'll take the derivative of -2x first, and leave y the same, and then leave -2x the same, and take the derivative of y with respect to time. Okay, and that'll be equal to the derivative of 28 with respect to time, which is just going to be 0. Okay, at time t equals 1, y is 2, and dx dt is -2. Okay, so I'm just going to plug in on all that stuff. And 4y cubed is going to be 4 times 8. Wait, we don't have dy dt, that's what we're hoping to solve. Minus 2 times dx dt, so that would be -2 times -2 would be +4 times y. And we don't, oh, we do have y, that's times 2. Yeah, I can work with that. Minus 2x, that's what I'm missing. Okay, so I need to go back to the original equation and figure out what the x-coordinate is when y is 2. So I'm going to plug in y equals 2 into the original equation that relates x and y. So 2 to the 4 is 16, minus 2xy would be minus 4x, that equals 28. Alright, so that means -4x would equal 12, and x would be -3. Dx, that's supposed to be dy dt. Okay, now I'm going to just start, kind of collecting some stuff. 8 plus 32 dy dt plus 6 dy dt, that's equal to 0. Okay, sure. Alright, so I've got 38 dy dt equals -8. dy dt equals -8 over 38. Alright, now we've got two objects moving on the x and y axes. Alright, I'm going to draw the diagram that I can come back to for both of these problems. Okay, object A has position x equals 5, and velocity dx dt equals -2. And then y has position 12, or b has position 12, and velocity is positive 1. Okay, so it's going up. Alright, so I think I've got everything I need here. Is the distance between A and B increasing or decreasing? Okay, so we need a formula for the distance. And that's going to be, you know, a squared plus b squared equals c squared, or x squared plus y squared equals r squared, whatever you want. Some kind of version of the Pythagorean theorem. So I'll say x squared plus y squared equals r squared. I'll take the derivative of both sides with respect to time. I get 2x dx dt plus 2y dy dt, and that's going to be 2r dr dt. Now I've got everything I need. I'm just going to plug in 2x is going to be 10 times dx dt, it was -2, plus 2y would be 24, and dy dt was 1. That will be 2r. Now if x is 5 and y is 12, r is going to be 13. So 2r would be 26 times dr dt. Okay, so if I've got -20 plus 24, I can solve for dr dt, and that would be positive 4 over 26, which is greater than 0. So I would say the distance between A and B is increasing. Right. Now we're going to consider triangle ABO, the right triangle with vertices at the origin, object A and object B. Okay. That's the triangle. Okay. I'll even highlighter it. Make it look like a triangle. Okay. And they're going to give us, no, it's the same time. Is the area of the triangle increasing or decreasing? Okay. Right, so we need a formula for the area. So the area of the triangle is going to be 1/2 times the base times the height. Okay, and if we want to determine if that area is increasing or decreasing, we need its derivative. So we take the derivative with respect to time, and that will be, okay, it's the product of 1/2 x and 1 y. So I'm going to say the derivative of 1/2 x is 1/2 dx dt. We'll leave y the same, and then I'll add in, leaving 1/2 x the same. I'll take the derivative of y, and that'll be dy dt. Okay. So I've got 1/2 times dx dt, which was -2, and y, which is 12, plus 1/2 of x and dy dt. Okay, so I've got -12 plus 2.5, that's less than 0, so I'm going to say dA dt is negative, so area is decreasing. Yeah, that's all for form I. Form J is pretty much the same. It's going to be, okay, 5WH, we're going to need to use the product rule on this if we're going to take dV dt. So I'm going to look at this as the product of 5W and 1H. Okay, so if I take the derivative of 5W with respect to time, that'll be 5 dW dt. And I'll leave H the same. Then I'll leave 5W the same, and I'll take the derivative of H. And yeah, that's dV dt. Right, if I want to find d theta dt, I need to take the derivative of arctangent of y with respect to time. Okay. So on the outside, I've got the arctangent, and on the inside, I've got y. Okay. The derivative of arctangent of a thing, which we do definitely need to know, is 1/1 plus that thing squared. And the derivative of y with respect to time is just going to be dy dt. And we know that if we're taking a derivative using the chain rule, we multiply outside prime times inside prime. So this is 1 over 1 plus, okay, whatever went in there is whatever went in arctangent originally, and that's y. Okay, so 1 plus y squared multiplied by dy dt. Area is going to be 6 pi h, and we'll find dA dt. Right? Well, 6 pi is just a number, so this derivative will just be 6 pi times the derivative of h. Alright, now there's a liquid spill in the hallway in the shape of a circle, and at 10:30 a.m. the radius of the spill is 30 inches, and it is increasing 4 inches per minute. We want the rate of change in the area of the spill. Okay, so I need to take the derivative of this area formula. Okay, the derivative of r squared is going to be 2r times the derivative of r for the chain rule because the radius is increasing. So we need to have that in our formula. Okay, so I think I've got everything I need. The radius is 30. The rate of change of the radius with respect to time is positive 4 because the radius of the spill is increasing. So this rate of change of the area is going to be 2 pi times r times dr dt. With one of these implicit equations where they start giving you dx dt and dy dt, we just need to take the derivative of the whole equation with respect to t. So the derivative of y to the 4 is going to be 4y to the 3 times dy dt for the chain rule. That's going to equal the derivative of 75 minus, okay, and then I'm going to look at this as plus negative 2xy. So my product is going to be negative 2x and positive y. So I'm going to take the derivative of negative 2x, and that would be negative 2 dx dt, and leave y the same. And then I'll leave negative 2x the same and take the derivative of y. Okay, because I just did this problem on the last form, I know that I'm going to have to, they give you y, but we're going to have to solve for x. So y is 3, 3 to the 4 is 81, equaling 75 minus 2x times 3, so 75 minus 6x. I think that's going to mean x needs to equal negative 1, right? Yeah, 75 plus 6 is 81. Alright, so now I've got everything. Y is 3, so 4 times 27 would be 108. dy dt equals 2 times y would be negative 6 dx dt. Oh, wait, they told us dx dt is negative 2. So negative 2 times negative 2 times y minus 2x would be positive 2 dy dt. Alright, so I'm going to subtract 2 dy dt's. And I'd get 4 times 3 is 12. So dy dt equals 12 divided by 106, which we could write as 6 over 53, or we could just not. And it's already been quite a lot. Okay, now I've got this related rate situation with particle motion. So I'm going to draw my diagram. X equals 12. Yeah, I'm going to just, maybe I'll call that 12. Whoops. And that's object A. And the velocity of A is dx dt is negative 2. And then object B is on the y-axis, and y is equal to 5. And velocity is dy dt is positive 1. Alright, so the distance between A and B, uh-oh, that's not good. distance there is going to be, might call that r. Okay. And r squared equals x squared plus y squared. Okay. And I'm going to take the derivative of this equation with respect to time, so that's 2r dr dt equals 2x dx dt plus 2y dy dt. Okay. And then I'm going to plug in everything. Okay, so r, when x is 12 and y is 5, 5, 12, 13 is a Pythagorean triple. It's one that's good enough for the SAT too. But r is going to be 13, so I'd have 26 dr dt equaling 2x is 24 times dx dt was negative 2, plus 2y would be 10 times dy dt is 1. All right, so since dr dt is going to be negative 48 plus 10 is negative 38 divided by 26. Okay, that's negative, so the distance is decreasing. Right, and then triangle ABO is going to be, if that's A and that's B, okay, that's the origin. That's going to be x, and that'll be y. Okay, so the area of this triangle is going to be 1/2 times x times y. And let's see, about like that. Alright, so my area formula will be 1/2 times x times y. If I want to take the derivative of area to determine if that area is increasing or decreasing, I'm going to need to use the product rule. So I'll take the derivative of 1/2 x, it'll be 1/2 dx dt, and leave y the same. Then I'll leave 1/2 x the same, and take the derivative of y with respect to t, and that's dy dt. Okay, and then I'm just going to plug everything in. I've got 1/2 dx dt was negative 2, I can see up there, and y was 5, plus 1/2 x was 12, and dy dt was 1. Okay, so I've got half of 12 is 6, minus 5 is equal to 1. Okay, so since dA dt is greater than 0, I'm going to say that area is increasing. Alright, and that's all of the Unit 4 quizzes. Thanks for watching. Hope this helped.